So dear friends, we are learning a second geometric transformation as rotation. We have already learned first geometric transformation as translation. So this one is the second geometric transformation which is used to rotate a graphic element about the origin or a point. So we'll see the analytical treatment or what is mathematics behind this geometric transformation as the rotation. So we are considering a point as a geometric entity, point P x y. This particular point P is located at a radial distance r from this origin. So these are x and y axes. So suppose this point is oriented at an angle phi with respect to this x-axis. Okay. So this point phi, we will call it as the original point. Now, before rotation of this particular point, we will find the horizontal distance, means this distance along x-axis, and vertical distance, means this distance about y-axis. Now this distance along x-axis can be denoted by x and can be found by taking the projection of this particular point on x-axis. Projection is nothing but shadow of this particular point on x-axis as well as projection of this particular point along y-axis. So this distance. So this distance will be a y distance. Now this x distance will be r cos of phi, and this vertical distance along y-axis will be r sin of phi. Okay, so this distance is r sin of phi. Suppose we will rotate this original point from this position to some another position at the same distance. Suppose this is the second rotated position. So we will call it as a rotated point. So we'll denote this as P dash with coordinates x1 dash, x dash comma y dash, and this distance will remain as it is. So this distance will be radial distance because we are just rotating this point from this position to this position with a distance of r. Now here our aim is to find this particular distance. Now this distance is x dash. Our aim is to find this x dash, which is equals to, see here, we are rotating this particular point P from P to P dash by an angle theta. So this particular angle is theta. So here this total angle will be theta plus phi. So projection of this point P dash on x-axis is x dash equals to r cos of theta plus phi. Similarly, this particular distance is y dash. Can anybody tell this distance or projection of P dash along y axis is y dash? So we can write y dash equals to r sine of theta plus phi. So x dash we can write as, we are knowing the addition angle formulae. So for this cos theta plus phi, we can write r cos of this theta, then cos of phi minus this r, again multiply. So r sine of theta sine of phi. Okay, so cos theta cos phi, sin theta sin phi. So for y dash we can write r sine of theta cos of phi plus cos of theta sine of phi. Again here there is multiplication of r. So instead of this r cos of phi, what we can write? We are knowing that r cos phi is nothing but x. So we can write x for this r cos phi. Okay, similarly for r sin of phi, we can write y. Again, r cos of phi, so x we can write, and r sin of phi we'll write as a y. So we can rewrite these two equations as x dash equals to x cos of theta minus y sin of theta, then y dash equals to, for r cos of phi we can write x sin of theta minus, plus r sin of phi, so we can write y, and this one as a cos of theta. So this is equation 1 or equation 2. So as our regular method, we can write these two equations in matrix form as, so x dash y dash. So we can write cos of theta minus sin of theta, then sin of theta and cos of theta. In second matrix, x and y. So this particular point we can write as P dash. Then this is the rotation matrix denoted by R, and this one is our original point. So we can write this P dash equals to this R and P. So rotated point, or we can say the coordinates of rotated point. This one is a rotation matrix and this one is original point, or coordinates of the original point. So I think you are getting what is exactly rotation is. Now there are two sign convention in this case. See here we have rotated this original point from its initial position to final position by an angle theta. Means here we are rotating in anti-clockwise direction. Okay, so this is the anti-clockwise direction. When we are rotating an entity in anti-clockwise direction, in that case we will take the sign of theta as positive for CCW. CCW is nothing but anti-clockwise or counterclockwise rotation. CCW rotation. If theta we are taking negative, means we are rotating that particular entity in clockwise direction, and vice versa. Means what? If we want to rotate the entity in clockwise direction, we have to consider theta as negative, and vice versa. These two things you have to keep always in the mind. So let us see, or before that, one thing is remaining. See here we have considered a geometrical entity as a point. We have considered point for a sake of convenience. You can consider a geometric entity as a line. Suppose this line PQ, and we have rotated this particular point about origin. So this will be your P dash and Q dash, x1. So you are rotating point P to P dash, again Q to Q dash, means you are rotating the entire entity about origin. Means you can rotate all the points of this particular geometric entity. Now we will solve one numerical. So consider a line PQ having a coordinates. Consider a line PQ having coordinates P represents 2, 3 and Q represents 7, 8. Is rotating about origin. Is rotating about origin. Now this particular word is very, very important. Hence onwards we will rotate the geometric entity about a arbitrary point, about some point. But before that we are learning this rotation about origin only by an angle theta equals to 30 degree in clockwise direction. So how to solve this particular numerical? Students, as per the data given in the numerical, we are proceeding for solving this numerical. So we are knowing how to find P dash and Q dash.